Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to y into f of y by x by eliminating the arbitrary function f. Okay. So we are given an equation or a relation z equal to y into f of y by x, and we are asked to form a partial differential equation by eliminating this f. Okay. Let's see. Given z equal to y into f of y by x, consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Okay, just apply dou by dou x on both sides of 1 or do directly. You can skip this step, okay? Fine. This gives us dou z by dou x equal to, since we are partially differentiating with respect to x, so we'll treat y as constant. Here y is treated as constant, okay? We can write this as y into dou by dou x of f of y by x. Since we have a notation dou z by dou x equal to p, let's replace dou z by dou x now. We'll get p equal to y into partial derivative of f of y by x. You can just write this as, we can find partial derivative of f of y by x. We'll get f dash of y by x into inner derivative, that is dou by dou x of y by x. Since y is constant, right, so we can write this as p equal to y into f dash of y by x into constant y into dou by dou x of 1 by x, or we can write dou by dou x of y by x as dou by dou x of y into 1 by x. Now take this out, we'll get y into dou by dou x of 1 by x. Okay, fine. This gives us p equal to y into f dash of y by x into y into partial derivative of 1 by x is minus 1 by x square with respect to x, right? Okay, fine. Which gives us p equal to y into y square into minus 1 by x square is minus y by y into y square into minus 1 by x square is minus y square by x square into f dash of y by x. Consider as some equation number 2. Now let's partially differentiate it with respect to y. Partially differentiating one with respect to y. Okay, just apply dou by dou y on both sides of 1. Here we are partially differentiating with respect to y, so we'll treat x as constant. Okay, now we'll get dou z by dou y equal to partial derivative of uv. Here we are going to apply uv formula, that is uv whole dash, which is u dash v plus v dash u. This gives us dou by dou y of y into f of y by x plus y into dou by dou y of f of y by x. Okay, better. Since we have a notation dou z by dou y equal to q, so let's replace this by q. We'll get q equal to partial derivative of y with respect to y is 1 into f of y by x plus y into partial derivative of f of y by x is f dash of y by x into inner derivative, that is dou by dou y of y by x, right? Here we have dou by dou y of y by x, right? Since we are partially differentiating with respect to y, so we'll treat x as constant. We can write dou by dou y of y by x as, we can split this fraction as y into 1 by x, right? Here 1 by x is constant. Now we'll write this as 1 by x into dou by dou y of y. Okay. Fine. This gives us q equal to 1 into f of y by x is y by f into y by x. Sorry, f of y by x plus y into f dash of y by x into, we can write this as 1 by x into dou by dou y of y, right? This gives us q equal to f of y by x plus y into f dash of y by x into 1 by x into partial derivative of y with respect to y is 1, which gives us q equal to f of y by x plus y into f dash of y by x into 1 by x into 1 is 1 by x, which gives us q equal to f of y by x plus y into 1 by x is y by x into f dash of y by x. Okay, consider as equation number 3. Okay, fine. Or we can write the same equation as q minus f of y by x equal to y by x into f dash of y by x. Consider as equation 3. Okay, now using 2 and 3 we'll find partial differential equation. Now see, either we can consider equation 3 and replace f dash of y by x using equation 2 and replace f of y by x using equation 1, or we can do 2 by 3, then we'll get LHS of 2 by LHS of 3 equal to RHS of 2 by RHS of 3 where f dash of y by x gets cancelled. Okay, we'll get p by q minus f of y by x equal to minus y square by x square into x by y. We can write y square minus y square by x square over y by x as minus y square by x square into x by y, right? 1x and 1y gets cancelled and you'll get p by q minus f of y by x equal to minus y by x. Now take this term to RHS, you'll get p equal to minus y by x into q minus f of y by x. Since we have z by y equal to f of y by x, okay, from 1 you can just bring this y to LHS, you'll get z by y equal to f of y by x. So you just replace f of y by x with this z by y, then you'll get p equal to minus y by x into q minus z by y. Okay, just simplify it. P equal to minus y by x into qy minus z by y, which gives us p equal to minus qy square minus into minus plus z into y by xy, or this gives us pxy equal to minus qy square plus zy. Now bring this term to LHS, you'll get pxy plus qy square equal to zy or yz, which is the required partial differential equation. Or take y common from all these terms. Okay, see, you'll get y into px plus qy equal to yz, right? This y gets cancelled, and which gives us px plus qy equal to z, which is the required partial differential equation. Therefore, px plus qy equal to z, or z equals to px plus qy is the required partial differential equation. Or this is another way. We have q minus f of y by x equal to y by x into f dash of y by x, right, from 3. Since from 1 we can just write this as y into f of y by x equal to z, okay, which gives us f of y by x equal to z by y. From 1 we have f of y by x equal to z by y, and also from 2. So we have 2 p equal to minus y square by x square into f dash of y by x, right? From this, just bring this term to LHS, you'll get minus px square by y square equal to f dash of y by x. From 2 we have f dash of y by x equal to minus px square by y square. Just replace f dash of y by x using this and replace f of y by x using this. Then this becomes q minus z by y equal to y by x into minus px square by y square. Okay, cancel x and 1 y. Now simplify it, we'll get qy minus z by y equal to minus p into 1x by y. Cancel this y, which gives us qy minus z equal to minus px, or qy, bring this to LHS and take this to RHS, you'll get qy plus px equal to z, or z equal to px plus qy. Therefore, z equal to px plus qy is the required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.